Welcome to YQ Academy, SQL, Interview Questions and Answers. 1. What is lock escalation? Lock escalation is a mechanism employed by database management systems to optimize performance and resource utilization by reducing the overhead of managing multiple fine-grained locks. It occurs when a database system converts multiple fine-grained locks on individual data rows or pages into a single coarse-grained lock on a higher-level structure, such as a table or partition. Lock escalation is triggered when a transaction acquires a large number of fine-grained locks on a particular resource, which can cause increased overhead in terms of memory usage and processing time for managing those locks. By escalating the locks to a higher level, the system can reduce the overall number of locks to be managed, resulting in improved performance and reduced overhead. 2. Explain the process of lock escalation. 1. Lock analysis. The database system monitors the number and types of locks held by a transaction and determines if lock escalation is beneficial based on predefined thresholds or policies. These thresholds can be based on factors like the number of locks acquired or the memory usage by locks. 2. Lock conversion. If the lock analysis determines that lock escalation is necessary, the fine-grained locks held by the transaction are converted into a single coarse-grained lock on a higher-level resource. For example, multiple row-level locks may be escalated to a table-level lock. 3. Lock release. Once the lock escalation occurs, the fine-grained locks are released, reducing the number of locks held by the transaction and freeing up system resources. 3. What is the difference between delete table and truncate table commands? 1. Speed. Truncate table is generally faster than delete table because it doesn't generate individual log entries for each deleted row. 2. Transaction logging. Delete table is logged in the transaction log, allowing for recovery and rollback, while truncate table is not logged, making it non-recoverable. 3. Identity columns. Truncate table resets the identity column values to their initial seed value, while delete table retains the identity column values. 4. Memory usage. Delete table uses more transaction log space and memory compared to truncate table. 5. Referential integrity. Delete table maintains referential integrity and triggers associated with the table, while truncate table doesn't trigger referential integrity checks or associated triggers. 4. Explain the storage models of OLAP. OLAP online analytical processing systems typically employ two storage models: multidimensional and relational. 1. Multidimensional model. The multidimensional model is specifically designed for OLAP systems and represents data in a multidimensional structure. It organizes data into dimensions, measures, and hierarchies to facilitate complex analytical queries and aggregations. Dimensions. Dimensions represent the descriptive characteristics of data, such as time, geography, product, or customer. Each dimension consists of a set of hierarchies, which provide a logical structure for organizing dimension members. For example, the time dimension may have hierarchies like year greater than quarter greater than month. Measures. Measures are the numeric or quantitative values that are analyzed in OLAP systems, such as sales revenue, profit, or quantity sold. They are associated with dimensions and provide the basis for calculations and aggregations. Cubes. The multidimensional model typically stores data in a structure called a cube. A cube is a multidimensional array that stores measures along with dimensions. It allows for efficient storage and retrieval of aggregated data, enabling fast query performance. OLAP operations. The multidimensional model supports various OLAP operations, including drill down, roll up, slice and dice, pivoting, and calculations across dimensions and measures. These operations enable users to analyze data from different perspectives and levels of detail. 2. Relational model. The relational model, commonly used in traditional relational database systems, can also be utilized for OLAP purposes. In this model, data is stored in tables with rows and columns, where each row represents a unique record, and each column represents a specific attribute or measure. Star schema and snowflake schema. In the relational model for OLAP, Data is often organized using star schema or snowflake schema designs. Star schema consists of a central fact table containing measures and surrounded by dimension tables. Snowflake schema extends the star schema by normalizing dimension tables into additional levels of related tables. SQL queries. The relational model uses SQL structured query language for querying and manipulating data. SQL queries can perform various aggregations, joins, filters, and calculations on the tables to analyze the data. Indexes. Indexes can be created on the relational tables to improve query performance. They allow for faster data retrieval by creating a separate data structure that stores a sorted copy of selected columns. 5. What are constraints? Explain different types of constraints. Constraints are rules or conditions that define the valid state of data within a table. They enforce data integrity and ensure that the data stored in the database meets certain criteria. Constraints can be applied to individual columns or entire tables. Here are the different types of constraints commonly used in databases. 1. Primary key constraint. A primary key constraint is used to uniquely identify each row in a table. It ensures that the primary key columns have unique values and cannot contain null empty values. A table can have only one primary key constraint. 2. Unique constraint. A unique constraint ensures that the values in the specified columns are unique, i.e., no duplicates are allowed. Unlike the primary key constraint, unique constraints can allow null values, but each non-null value must be unique within the columns. 3. Foreign key constraint. A foreign key constraint establishes a relationship between two tables, enforcing referential integrity. It ensures that values in a column foreign key of one table match the values in a primary key column reference key of another table. It maintains the integrity of relationships between related tables. 4. Check constraint. A check constraint allows you to specify a condition that must be true for the values in a column. It limits the range of allowed values based on the specified condition. For example, you can use a check constraint to ensure that an age column contains values greater than or equal to 18. 5. Not null constraint. A not null constraint specifies that a column cannot contain null values. It ensures that every row in the table has a value for the specified column. 6. Default constraint. A default constraint assigns a default value to a column if no explicit value is specified during an insert operation. It ensures that a column has a value even if one is not provided explicitly. 7. Identity constraint. An identity constraint is used to generate unique, incremental values for a column automatically. It is commonly used for primary key columns. The generated values follow a specific sequence defined by the identity constraint. This is the end of our SQL interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.